Okay, students, so today I'm going to actually go over the Chapter 1 final review. Since we were out of school for the last 2 days because of this frigid cold, I thought let's just do it at home. I can answer some of these questions for you, and you can watch these videos at home. Okay, so starting with number 1, identify the slope and the y-intercept of each line. Well, in this situation right here, sadly it's not in slope-intercept form, so we need to get it in that form. Once we have it in that form, we can find the slope. First step to doing that is subtracting the 2x. Subtract the 2x, so we have 3y is equal to 8 minus 2x. If I rearrange these, this turns into, well, let's not rearrange them yet. This next step would be divide by 3. Divide everything by 3. So once we divide everything by 3, what we have is y is equal to 8 thirds minus 2 thirds x. Now the slope is always connected to the x when you have it in slope-intercept form. So in this situation, our slope is right there. So m equals negative 2 thirds for that one. Negative 2 thirds. For this one, this is in point-slope form. What's nice about point-slope form is it actually gives you the slope right off the bat. Here's the slope right there. So m equals 6. Moving on to number 2. Number 2 says write an equation slope-intercept form for the line with a slope of 0 passing through the point negative 3, 4. Well, a slope of 0, if you were to graph that, it would be a horizontal line. That's a slope of 0. Now don't get that confused with the vertical line. This is the slope of 0 right there. That's a slope of 0. So let's do this. Okay, let's figure out on a coordinate plane where this point is. So we go over 3, 1, 2, 3, and down 4, 1, 2, 3, 4. And so that's where our point right there, 3, 4 is. And we know this has a slope of 0, so it's a horizontal line. So we'll just kind of get that line in there. Here's our line. Well, this line has no slope. So we have y equals no slope, or 0 slope, sorry, is 0x, because that's our slope right there, plus b, which is our y-intercept. Notice our y-intercept is right here, and our y-intercept is negative 4. So b is equal to negative 4. Well, 0 times x is just 0, so really we have y is equal to negative 4. That's our equation of a horizontal line, right there. Moving on to number 3. So write an equation in slope-intercept form for the line with an undefined slope passing through the point negative 1, 0. Well, this is a little different. The 0 slope is different than undefined slope. If we have a coordinate plane like this, an undefined slope is actually a vertical line, so something like this. So let's do the same idea. Let's make a coordinate plane right here. And on the coordinate plane, let's put this dot, negative 1, 0. So negative 1 and then up 0. So there's our point right there. And it has an undefined slope, so we know we have a vertical line, right? So we got... There's our vertical line right there. And really, the equation for this is a little bit special. Instead of y equals mx plus b, we don't do that in this situation. Vertical lines have the slope of x equals the x-intercept. Okay? So we just got to figure out what the x-intercept is. Well, when we look at this, what is our x-intercept? It's right there at negative 1. It's actually given to you right there, huh? Isn't it? So our equation is x equals negative 1. Right there. Okay, moving on to number 4. Number 4 says write an equation for the line containing the indicated points. Well, in this situation, what we're going to need to do is we need to fill in our m and our b right here. So y equals mx plus b. We've got to find the m and the b. Well, the m, which is our slope, can be defined by the equation y2 minus y1 over x2 minus x1. So we just got to figure out which point's the second point. Let's just say the second point. This is the first point right there. So y2 minus y1. Well, this is our y2, so that's 10 minus y1, which is 3. That's all over 2, x2 minus x1, which is 0. This gets us 10 minus 3 is 7, and 2 minus is 2. So our slope here is 7 over 2. So we got this part. That's done. Now we got to get the b. So what we're going to do is we are going to take this 7/2, plug it into our equation, and choose one of these 2 points, plug it in, and solve for that b. And let's take a shot at that. So let's take this, plug it in there. We'll rewrite this as y equals 7/2 x plus b. And we're going to take, this one has a 0. I like that. So let's take this and put it in there. Well, our 3, we're going for our y, and our 0, we're going for our x. So I have 3 equals 7/2 times 0. Oh, that's nice. Look at it, cancels off. Plus b. Well, 7/2 times 0 is gone. So I got 3 is equal to b. And if 3 is equal to b, we'll just put that in for our equation. Let's rewrite the whole equation here. Y equals 7/2 right there, x plus 3. That's from there. Okay? So that's how you kind of go about doing this problem right there. Let's try it one more time. Oh, sadly, this one doesn't have a 0 point, but maybe it will be a little bit easier of a fraction. So again, we got to find our slope. M equals slope equals y2 minus y1 over x2 minus x1. So let's figure out that slope. We'll make this our second point, that our first point. So we have 4 minus negative 5. That's tricky right there, right? 4 minus negative 5 all over 6 minus 3. Well, 4 minus negative 5 is the same as like adding. So we got 9 over 3, which is just 3. So our slope is 3. So let's rewrite our equation. Y equals 3x plus b. Still got to find that b. So choose a point. Doesn't matter, this one or this one. I don't like that negative there, so I'm going to choose this one in this situation. So we're going to put this in for our y right there, the 6 in for our x right there. So we got 4 equals 3 times 6 plus b. Let's just bring that right here. We have 4, 3 times 6 is 18, 18 plus b. So we'll subtract the 18 from both sides, subtract 18, and we get b is equal to minus 4. Hopefully I do this right in my head. I'm getting tired. Negative 14. There we go. So we'll take this, plug it back into our equation right here, and we got y equals 3x minus 14. That's our equation right there. Okay. Moving on, number 5. Write an equation slope-intercept form for the line with a slope of 2 that goes through the point 4, 4. Well, that's not too bad. So we already know the slope is given to us right there. And we got to have it in a slope-intercept form. That's y equals mx plus b. This sounds easier than the problems up here, right? So let's do this one. Here we got, let's see, we already know the slope, it's 2. So let's write that y equals 2x plus b. And we got a point. We know this line goes through this point, so we're just going to plug it in there. So we got 4 equals 2 times 4 plus b. So if we got 4 equals 8 plus b. Subtract that 8 from both sides, and we get b is equal to negative 4. Rewrite this whole thing by plugging this right in for there. So we get y is equal to 2x minus 4. And there's your equation. Okay. Moving on to number 6. Make sure I can get it in here. Yeah, there we go. So write an equation in slope-intercept form for the line that contains the point 3, negative 4, and is parallel to the given line. Okay, so parallel is the key word here, guys. If we have two parallel lines, something special about them. If we have this line, a parallel line, never crosses it. And if two lines never cross, we know that those two lines have the same slope. Okay. So looking at this equation, what is the slope of that equation? Well, thankfully it's in slope-intercept form, and we know the equation is 5/3. So m is equal to 5/3. So let's just use that for our new equation. So we got y is equal to 5/3 x plus b. Now we don't know our b yet, but thankfully we can plug this point in for our y and x and figure that out. So let's take this negative 4, put it for our y, equals 5/3 times 3 plus b. Thankfully 5/3 times 3 is really 15 over 3, because 5 times 3 is 15. 15 divided by 3 is 5, so I got negative 4 is equal to 5. Notice how that 3 cancels off that 3. Plus b. Let's subtract this 5 from both sides, and so I get b is equal to negative 9. We'll just plug that into our equation right here. I'll put that down here. So y is equal to 5/3 x minus 9. And there's our equation. Okay, moving on to number 7. So write an equation in slope-intercept form for the line that contains a point and is perpendicular. Okay, so perpendicular, we got a different scenario here. And when two lines are perpendicular, or one line is perpendicular to the other, let's just do that over here. So let's say we have this line. A perpendicular line has a 90-degree angle to that line, okay? And what's nice is we know how to find the slope of the perpendicular line. It's called the negative reciprocal, okay? So let's say the slope of one line is 1/2. The negative reciprocal of that would be to flip them. So you flip it. I'll spell flip right. So 2 over 1. You don't really need that one. And you change the sign. This sign was a positive, so you change this to be a negative. Okay? So that's how we have to do that. So let's look at this equation. Sadly, they made this one a little bit more difficult. They did not give us the slope as easily. We need to get the slope from this equation, so let's do that. Let's get in slope-intercept form. It's not too hard. We subtract x from both sides, and we get y is equal to 5 minus x. So we know the slope of this equation is -1. So the slope, it's not slope, the slope of the perpendicular equation, if you think of this as that, if we flip them, we just have 1 over 1 again, right? But this sign changes, so it's a positive 1 over 1. So our slope of our new equation will be y equals 1 over 1, but I'm just going to put 1, x plus b. Now let's take this point and plug it in there. Okay, so we're putting a 0 in for our y equals 1 times -4 plus b. 1 times -4 is -4. 0 will add 4 to both sides. Sorry, add 4. And so what I get is, oh, that's 4. What I get is b is equal to 4. Now I just take that, plug it in here. We'll rewrite the equation right here. Y equals, I don't need the 1 in front of the x plus 4. And there's your equation. Moving on to number 8. Okay, we need to write the equation in slope-intercept form. Oh, that's not good. Write the equation in slope-intercept form for the line that contains this point and is perpendicular to that. So this is just like this last problem, just a little bit more difficult when we're dealing with this. Step 1, find the slope of the current line. So we've got to find the slope of this. Let's do that. So let's subtract the 3x, subtract 3x. So we have -y. Don't lose that negative. It's equal to 1 minus 3x. Now we're going to divide by -1, divide by -1, divide by -1. We want to get that y totally by itself, okay? That cancels that off. So we have y is equal to 1 divided by -1 is -1. And -3 divided by -1 is 3x. Okay, so what's the slope of this line? Well, it is the slope, m, is equal to 3. Okay, what's the slope of the perpendicular line? M equals, well, there's nothing in the denominator, but there is. It's 1. So we flip it, so 1/3, and this was positive, so we make this one negative. So the slope of our new line is going to be -1/3. Let's take that and bring that over here. So we have y equals -1/3. That's a negative right there. X plus b. Okay, so now let's take this point, plug it in to our equation. We got -2 for our y, and then -6 for our x. So y equals -1/3 times -6 plus b. We got -2 is equal to negative times a negative is a positive. What's 1/3 of 6? Well, that's like 6 divided by 3. So we got 2 plus b. Let's subtract the 2, subtract the 2, and I got b is equal to 4. So that's my 4. I'm going to plug it in right here. So if I bring that down here, we got y is equal to -1/3 x minus 4. That's minus 4. Sorry, minus 4. And there's your equation. And number 8, done. Okay. Number 9, use your graphing calculator to create a linear regression equation for the data below. Describe the correlation coefficient. Shoot, I need to pause this, and, well, we'll come back to, well, yeah, okay, I'm pausing it. Stop recording. Okay, this next problem asks you to use a graphing calculator to create a linear regression equation for the data below. Describe the correlation. So in this situation, what we're going to do is grab our TIE4 plus graphing calculator. Move this up a little bit. There we go, you can see it now. And we are going to put this data in here. To do that, first you push stat. And you're going to go to this edit and push enter on edit. What we need to do is put the 0, 2, 5, 9 in for our L1 and the 5, 9, 15, 23 in for our L2. So let's do that. We've got 0, enter 2, enter 5, 9. Now the biggest mistake students make is putting in the wrong data. If you put the data in right, it's hard to go wrong or make a mistake on this problem. 15, 23. So we'll just double check 0, 2, 5, 9, 0, 2, 5, 9, 5, 9, 15, 23, 5, 9, 15, 23. Okay, so the next step, push that again. Okay. Now that I got this in here, let's zoom on out for you. Push stat again, right here, stat, and you go over to calculate, and you go down to this linear regression right here. Regression, once you get that in there, since we put our data under L1 and L2, that's kind of the default, so we don't have to put anything else after this, push enter. And it gives you y equals ax plus b. It tells you what the a is and what the b is. So there is your linear regression equation. You put y equals 2x plus 5. So y equals 2x plus 5. And so we got a positive correlation here going on. that starts at 5 and it goes up at a rate of 2. That's kind of just description of this correlation. Next, it asks true or false. The correlation coefficient can be -2. Oh, that's not true, because we know the correlation coefficient is only between -1 and 1. That's what the correlation coefficient is. And if you guys remember, correlation coefficients are R has to be greater than -1 and less than 1. If the slope of the line is negative, this is part B, the correlation coefficient is negative. That is true. That is true. This one also false. And lastly, a data set with an R of -0.72 has a strong linear relationship, a stronger linear relationship than a data set with 0.64. Exactly, that is true. The stronger the relationship it is if it's closer to -1 or 1. Okay? This is closer to -1 and this is closer to 1. Therefore, this has a strong relationship. Yes, it's negative. Doesn't mean it's not a strong relationship. It's a really strong negative relationship. So a data set with an R equals -0.72 has a stronger. This is true. And that is the end of page 1.